Welcome to the Data Future channel. This is Shekhar and I am a data scientist. So in this tutorial we are going to see the end-to-end deep learning project. So let's get started. So first we have to import the required libraries. Now here I am importing pandas, numpy, keras, then keras.model, then in that the sequential and keras dot layers I'm importing the dense. So later in the course I'll explain this concept. So when you run this, then we are having now required libraries here. Now the second part is we have to load the data. So here I'm considering the data which is related to the employees data actually. This is very simple data which is having 10 columns and almost 14,999 records. So these are the columns. So if you want to see the column names, then we can check that also. The columns in the data, these are the columns, and ultimately we are going to see whether there is any missing values are there or not. Is null dot sum, okay, sorry, my bad, dot sum, and we can check there is no missing values present in the data set, so we need not worry about the missing values. The next one is yes. So whenever we are working on any machine learning models, in that case, what we have to do, you just have to convert all the categorical columns into a numerical one. Now here is department and salary is the categorical column. So rest of all are the numerical one. So meanwhile, we can also check what is the information about this data set. So we'll get the idea. Yes, now you can see here, these all columns are the numerical except this department and salary. So we have to convert this into numerical columns by using one hot encoding. So here are I'm selecting the two columns and applying this pd.getDummies. This is employee data, and which columns I need to convert into numerical, that column list I am providing, and then drop first means I am removing that the column categorical column. Okay, so I need to run this. Yes, now you can see some sample data uh, here. Okay, now you can see here, yes, uh, now we got these values and now our data is changed. Okay, so that values are changed from here is true, rest, um, uh, rest we have considered. So department ID, um, department R&D, accounting, you can see now these the categories are converted into columns. Now we have to check what is our dimensions or the shape of the data here. Now you can see here, now these columns, these 10 columns are converted into 19 columns. Okay, means there are dummy columns are added based on the one hot encoding. Okay, yes. The next one is we have to decide the what are the dependent and independent variables. So dependent variable is basically x, independent variable is basically x, and dependent variable is y, which is the target variable. So this is our target. So what is target? So target is we need to predict from this whether that employee will left the company or not. So this data is all about the employee attrition. Okay, so we can predict whether that employee will stay with the company or not. Okay, so this is all about the dependent and independent variable. The dependent variable is called target variable. Independent variables are these are the features um, on the which impact the target variable. Okay. Next thing is we have to split the data. So as usual, we are splitting the data into 70 to 30, 70% and 30%. So I'm considering the training is 70% and testing is 30%. And if you check the final shape of this, because we have removed one uh, from this, these are the independent. So one dependent is removed. So there is 1800 sorry 18 columns are there, and these are the train records. Okay, so this is the training set actually. So before going into this, because we have to check what exactly it is, because these are the numerical one, so we have to we have to convert or scaled bring this all the features on the same scale. So for that we need to use the feature scaling. And feature scaling, there are two options. One is the standardization and second one is the normalization, or here is the standard scaler we are using, or you can use the min max scaler also. Okay, so here we are running this scaling this the features. Okay, so here I'm creating a standard scaler. I'm importing the pre standard scaler from the pre-processing and creating the object of standard scaler, and I'm applying fit and transform to xtrain, and I have to transform the xtest data. Okay. Then the next phase, next step is very important step where we are going to build the artificial neural network. So you can see here we are going to use the keras to build the deep learning model. So we have already imported keras, okay, which will use the TensorFlow at the backend by default. From keras, you have to import the sequential model to initialize the artificial neural network. In artificial neural network, the computational model that is built using the inspiration from the working of human brain, you will import the dense model as well, which will add the layers to the deep learning model. Okay, when building a deep learning model you are usually specify the three layers. The first is the input layer. So in input layers you have to pass your features of the data set. There is no computation occurs in this layer. Okay, it serves the past features to the hidden layer. Okay, in hidden layer usually layers between the input and output layer, there all type of the computation is happen and pass the information to the output layer. Okay, the output layer represents the layer of neural network that will give you the results after training your model. It is responsible for producing the output variable. So this is all about the how we can build the artificial neural network. Let's get started. Here already we have imported this keras, the keras.model, then sequential and keras.layers to import the dense. Okay. Now you will use the sequential to initialize the linear stack of layers. Since it is the classification problem, you will create a classification classifier as a variable. You can take any variable. The classification problem is the task where you have to label data and would like to make some prediction based on the label data. Add this code to your notebook to create the classifier variable. So here I'm creating the object of this classifier, and I'll say it's classifier. I'm giving here name 001. So I'll run this. Okay, now my classifier uh, is ready. Now what I have to do, uh, we have to add the layers now here. Okay, layers. So this classifier I'm using here to add the layers. Now we are adding dense. This is the unit. So this unit is basically use the number of nodes basically. So these nodes are the average of nodes are available at the input and the output. So in the output our features are 18 features. So we know that this data set here 18 features are there, means 18 columns simply. uh, these 18 columns we are giving as the input dimension, and these units are nothing but the average of input and output. Okay, so output will be 1, and input dimensions input node will be 18. 18 plus 1 is 19, divided by 2 is almost a 9.5, so we are taking this unit as a 9. Okay, so second one is the kernel initializer. When you feed a deep learning model, the weights will be initialized to the number close to 0 but not 0. To achieve this you have to use the uniform distribution initializer. So the weights are we have to initialize by using this uniform. Okay, then there is the activation function. So activation function brings the non-linearity. Okay, um, brings the non-linearity to the information. So we are using here the ReLU as the activation function because linear functions are not good for this problem. So we are not using any linear functions. So we have to convert the non-linear data. And finally, the input dimensions are 18 here. So this is our classifier. We have added the layers here. Okay. Now next one is we have to add the output layer. Okay. The hidden layers we have added. Okay, now we have to add the output layer. So output will be your 1. Okay, and kernel initializer will be uniform, and activation function will be sigmoid because it's a 0 and 1 type. Okay, so already we know the kernel initializer sigmoid function, so that you can get the probability that employee will leave or not. Okay, from that sigmoid functions. In the event that you are dealing with the more than 2 categories, then you have to use the softmax activation function, but which is the variant of sigmoid activation function. But here there is we have to predict the probability. Okay, so next here we have to compile this. So I have to use this classifier here, not that one. Okay, now it is updated. Now what you have to compile this, and here we are using Adam as a optimizer. We have to use the loss function, that is binary cross entropy, and the accuracy is the matrix one. So basically what happens here, when we apply a gradient descent to the neural network here, we have to use the optimization strategy to reduce the errors during the training process. The gradient descent is how randomly assigned the weight in the neural networks are adjusted by the reducing the cost functions, which is the measure of how well neural network is performing. Okay, the aim of the gradient descent is to get the least error, and so that we can minimize the cost function. Okay, which is refers to as the local minima. Um, so that we have to apply the optimization strategies here, and for that the optimizer used, which is popular one, that is the Adam optimizer. Okay, so here I'm running this cell, and after that I'm fitting this classifier to our training data set. So I'm training this training phase is here. So training will be carried out here. So training of the model, deep learning model, I can say here. Yes. Now, when I run this, there are two parameters are also there. One is batch size and the epoch. Okay, what exactly is the batch? Batch size is represent the number of samples that will go through the neural network at each training round. Okay, and the epoch represent the number of times that data set will be passed via a neural network. Okay, so how many times we are passing this 10 uh, batch size of 10 sets into that particular neural network to adjust the weight and to reduce this the errors, and for that we have to use the batch size and the epoch as the parameters. Okay, here, so that if you select the maximum number of epochs, so what will happen, it will take longer time, and but it will give the better results. Now you can see we have selected only two epochs, so within that these two epochs our efficiency is accuracy is improved from 78 to 84%. Okay, fine. So we will run the test, so we'll check, we will using this classify 0 0, here the classify 0 0, and then we are going to predict y predict. So now the y predict is available with us, we can check that matrix of y predict. Now yes, we will check how many of having the probability is greater than zero point 0.5, because we know that if if the probability is more than zero point 0.5, then it will be, the result will be 1, otherwise 0. So here I'm using that, and here you can check what exactly this is. Yes, false, it will give the false to like 0101, something like that. Okay, now next one is we will evaluate this model by using a confusion matrix, and confusion matrix is nothing but n by n matrix, where we are checking the true positive, false positive, and true negative, something like that. Okay, so here I'm using this confusion matrix. Next one is we will use one single prediction. We'll check for the single prediction here. So let me copy this classifier, because classifier 0 0 we are using, so that we have to use that classifier exactly. Yes, now I'm running this. Yes, now yes, so before putting our array, means that the input data, we have to transform it, because already we did this scalar transfer standardization. Okay, so we have to transform, and then you have to give the input to the model, then it will predict. Now we will check our prediction. So prediction is 0.24, means it is not greater than 0.5. So answer will be 0 or no for this particular case. Okay. Yes. Now next one is the, we are checking the what is the accuracy. Already we know that the what is the accuracy of this particular model, but once again we are checking its almost accuracy is 86%. Okay. So That is one. So you can check the precision. Recall is not that one good for this for this case. F1 score, and this is not a good one. Actually, there is no balance. Okay, fine, but we can also improve the accuracy of the model. So how the accuracy can be improved? By using a cross validation. So for that we will use the cross validation here for this particular case. Now you can see here I am using these two functions here. So from Keras I'm importing wrapper, then dot scikit-learn, and then Keras classifier I am importing, and from here I'm importing the cross val score. Okay, sklearn dot model selection. Yes. Now I'm writing the function here, the same functions which we have created this model earlier. So make classify the functions, the model which we have used here, the same I'm using, as these are the function, the only yes, and I'm making as a classifier. Now here I'm creating a new classifier. So this new classifier I will say it's a 0 1 here. Okay, this Keras classifier will take these make classifier as a function as the input here. Batch size I'm taking 2, and number of epochs I'm taking only 1. Okay, so again I have to run this. Now our new classifier is there. Okay, now this function, then batch size and epochs I am considering 1 only. Now I have to consider the cross-val score, and estimator is this classifier. We have considered classifier here, giving the input extend y-train 10 cross validations we are considering 10 folds, and n jobs I'm using what number of CPUs. Okay, whatever available CPUs I'm using here for n jobs. Okay, and I'm storing this accuracy here. So I think it will take some time, because it will there are 10 k folds we have selected for that. Okay, so you can see 1 2 3 4 5 and 5 10. So we will get the 10 accuracies, and in that accuracies it will consider the training data set. We will create a 10 data sets for training, and check um, the accuracy for that particular um, data set. So also it will take certain time. Let's wait. So uh, then yes, let it will take certain time to give the output of these accuracies. Meanwhile, we'll check this step once again, because we have to improve the accuracy and these things. So for that, what we are using the cross validation. Okay, so this is very important part, the Keras classifier we are considering, and in the Keras classifier we have to give the three parameters as the input. One is built function. That function is nothing but our classifier. Okay, make classifier, and batch size, and epoch that we are giving. Yes, now our accuracies are ready with this classifier, and I will check the list of accuracies. Now you can see here these accuracies. You can see the 10 accuracies. Now I want the mean of this So mean of this, it will give what exactly? It's 84%. Okay, and we'll check the variance. So variance is reduced. So I'm putting here the variance is 25 because every time that will change. Okay, now this is all about the accuracy. We improved this accuracy. You can check. We have checked this one, but how to avoid the overfitting problem in the deep learning or in neural network? So what exactly happens? So whenever our neural network learns from the training data set, so it cannot be able to generalize, so that will get the more if accuracy on the training and less accuracy on the testing one. Okay, so how to avoid this? So avoid this overfitting in the neural networks, and for that we are having one dropout regularization. Okay, so we can inactivate some of the neurons so that it can generalize. It will not memorize the what is there in the training one, so it will generalize the solution. Okay, and for that we are using adding the dropout layer in the neural network. So to avoid the overfitting, we are adding here from keras.layers, we have to import the dropout, and again we have to create a classifier. So I'm creating some other classifier here. So I'll say it's 0 2. Okay, and this classifier I'm going to use everywhere. Okay, and you can see here the same kind of things we have already used here. Only thing is we have added here dropout and the rate is zero point 0.1. So zero point 0.1 means what? We are specifying how much percentage of neurons will be deactivated during the training process. The remaining network will remain as it is. Okay, so 1% of neurons we are deactivating during the training, so that the model will learn different things from the training data set. Okay, so um, so the rest of the things are same. Adam, this binary cross entropy, and this is the accuracy. So I'll run this. Okay, fine. And uh, here uh, you can uh, check the accuracy by using this classifier also. Okay, so by using this classifier, let me check. Okay, now I have to check how this the classifier work. Okay, yes, this is classifier. I am expecting the only two epochs I have considered, and the batch size is 10. Okay, let me run this. Okay. Oh, okay. Now you can see here we have changed the classifier, and there is a improved the accuracy. Okay, that's fine. Okay, we can use this for the prediction also. That is not the issue. Okay, this is all about how we can add the dropout layer. Now next one is how we can increase, how we can tune the hyperparameters. Okay, so hyperparameters can be tuned by using this thing, uh, using grid search CV. Already we know that, and here we are using the same thing everywhere. Okay, but using a grid search CV. Now this classifier I'm building is third classifier, and I'm using this as a built-in function, and I'll run this. Okay, now next one is I have to decide the parameters, which parameters, hyperparameters I have to provide, so that the model can find the best parameters and the best accuracy. So here I'm considering the batch size is 20 and 35, epoch is 2 to 3 I am considering, and the optimizer Adam and RMS prop. These uh, parameters I'm considering, and I'm using this in a pipeline and considering from two cross validations here. So classifier 3 I'm considering as the estimator here. Okay, and I'm running this. Okay, yes, let me run this, and I'll check. Yes, this one, and I'll search for the this one. So epoch 1, check the losses are decreasing. Okay, it is trying the every possible combinations of this, because we have considered this parameter, so uh, it will consider each and every grid, okay, possible combinations, and calculate the accuracy. Okay, so yes, it's still running. 9% accuracy it is giving, somewhere it is 78, because this is changing continuously parameters, looking for a best combination here. Oh, trying all possible combinations and checking for the accuracy, and when it stops, then we'll get the best parameter and the best accuracy out of that, out of selected parameters, because we have selected these parameters. So based on these parameters it will calculate the accuracy and the best parameters. Oh great, it stopped now. Now we have to check what is the best parameters here for this particular case. Yes, the best parameter is, you can see, a 20 epoch, no sorry, 20 batch size, 3 epochs, and Adam optimizer, and the best accuracy is 86%. Oh, I need to change this here. The optimizer, best optimizer is Adam, and number of epochs are 3. Okay, and yes, accuracy is increased to by 2%. Okay, great. So now 86%. Okay, means you can predict the employee attrition uh, with accuracy up to 86%, whether that employee stay with the company or leaves the company, based on the different attributes of that particular employee. So this is all about this end-to-end project in deep learning with employee attrition prediction. Okay, thanks for watching. Please do subscribe my channel, and let me know if you have any doubts. Then you can reach out to me at ssbarber1984 at gmail.com, and 976440 03270 on, or you can call me on this number. Okay. Yes. Thanks for watching. Bye.